Jackpots this time.
Yo, what's going on, guys? I am back with another video. This is going to be a video over your vector test review. I hope it helps. Let's get started. Oh, 1 second, I forgot to forget. I was talking about the video. Hey, I wanted to, and I normally never do this, I wanted to shout out James Wavy. Y'all know him as James. All right, hey, he's got this YouTube channel where he's talking about how you get those waves spinning. All right, so check it out. Anyway, back to the math. Hey, so here we go. We have this first problem here. It says, for each vector given below, find a component for it. Now, the thing I want you to first pay attention to is, those are points. That is a coordinate point D and a coordinate point E. All right, again, that's a coordinate point. So we take the coordinate points, guys, and we're going to use this rule right here. All right, and the rule, we're going to do x2 minus x1, comma, y2 minus y1. All right, and that will give us our vector or our component form. All right, now x2, x1, y2, y1. All right, so D is going to be the first x and the first y, and E is going to be the second x and the second y, like that. Okay, so we plug everything in. We're going to do 3 minus a -2. All right, and then we're going to do 8 minus 5. All right, so x2 minus x1, y2 minus y1. Now the thing I want you to notice right here is, see the two negatives? All right, two negatives become addition, so we have 3 plus 2 is 5, and 8 minus 5 is 3. Guys, there's our component form right there. Now, for number 2, again, we have 2 coordinate points on the graph, guys. All right, I'm going to do PQ just because alphabetically P comes before Q. You can do them either way. It doesn't matter which one you do first for X1, X2. It's going to all work out. All right, so for this one, all right, I'm going to do 4 minus a -1. All right, and then I'm going to do -7 minus 5. So doing so, 4, that becomes a plus again, right? 2 negatives is a positive. So 4 plus 1 is 5, and -7 minus 5 is going to be a -12. All right, so there's our component form right there. All right, for this next one right here, we got to find our component form. Now notice here, they gave us the degree, and they gave us a vector, a magnitude, and we got to make our vector. So this rule right here, when you're given these things, the first thing you got to do is remember to find, or here, I'm going to write them out separately. Well, no, I'll write it out. So to get our first value in our component form, our x value, all right, we're going to do the magnitude of V times cosine of theta. All right, and then we do the magnitude of V, our vector, times sine of theta. All right, so they gave us theta. All right, they gave us our magnitude. So now it's just substitution. All right, 32 is theta, and the magnitude is 48. So when I do this vector, excuse me, I used the wrong bracket type right there. So when we do this, we end up with the magnitude of 48, cosine of 32 degrees. All right, and then we end up with the magnitude of 48 times sine of theta. Now, one thing I want to point out to you is this. This value is not an exact value. Well, we won't get exact values. We got to use our calculator because this is not on a unit circle. All right, if this was on a unit circle, guys, then obviously you would use the values from the unit circle. Okay. Now, before I start, well, no, let's just go ahead and punch it in. I realized I made a mistake right there, and I want to fix it. So I'm going to fix that value. Instead of theta right there, put 32. 32. There we go, 32 degrees. Now, I punched this into my calculator, so we have 48 cosine of 32, and that is going to give us a 40.7. And right here again, we do it again, but we're going to go sine this time for 32. Hey, and by the way, when you do these, make sure your calculator's in the right mode. You should be in degree mode because 32 degrees. All right, and that's 25.4. All right, so there's our component form right here. Okay. Now let me zoom in a bit. So, all right. So for this one right here, solve each vector problem. Show your setup. Listen. Understand, these are vectors, guys. They're not coordinate points. Like up here, coordinate points have these parentheses. All right, vectors have these brackets. Okay, so let's be mindful of that when we evaluate these problems. It's already a vector. All right, you do not have to use this concept right here. These are points to make a vector. All right, I'm just trying to reiterate that because they're vectors. So don't do the same process. Right here, you just apply the operations. I got a multiplication right here, and I got a subtraction. So we're going to do 2 times u. All right, minus v. All right. So first, we're going to distribute the 2. All right, so that gives us negative 6. 12, and we have minus 4, 2. So now, listen, all we do is we're going to subtract the first terms because it's subtraction, and then we'll do the second terms. All right, so we do negative 6 minus 4, and we do 12 minus 2. So negative 6 minus 4 is negative 10, and 12 minus 2 is 10. All right, so there we go. All right, we get negative 10, 10. All right, for this next one right here, we have negative 3u plus 2v. So let me make this bigger so I can have more space to write. There we go. One more adjustment. All right. So we have negative 3 times 10, negative 3, plus 2 times negative 2, 4. So we distribute the negative 3 to have negative 39. And we distribute the 2 to have negative 4, 8. And now we add the first terms. So negative 30 plus negative 4 plus negative 4 is negative 34. And we have 9 plus 8, 17. Okay. For this one, u minus v. So I have 4, 5, vector 4, 5, minus negative 3, vector 3, 2. All right, negative 3, 2. All right, so look, listen. 4 minus negative 3. And 5 minus 2 gives us, right here, that becomes a plus, so that's 7. And that right there is going to be 3. Okay. It says find a dot product of 4 through 6. So we're going to use these actual values right here. So I'm going to make this smaller again so I can see everything on the screen. So remember dot product, guys. All right. When you have vector u, I'm going to say u1 and u2. All right. And vector v1 and v2. Dot product is u1 times v1 plus u2 times v2. All right, that's the rule. So what do we do with that rule? We're going to apply it to all our vectors. Sorry about that. So for this first one right here, we have, what's that first one? Negative 3, 6. So negative 3, 6, 4, 2. All right, so we're going to do negative 3 times 4 plus, all right, plus 6 times 2, which gives us negative 3 and 4 is negative 12. That's 12, which is 0. So the dot product of this first two vectors is 0. All right, right here, number 5, we're going to use those component forms. So 10, negative 3, and 2, negative 2, 4. So we do 10 times negative 2 plus negative 3 times 4. So 10 times negative 2 is negative 20. And negative 12. Negative 20 plus a negative 12 is negative 32. All right. Right here. Number 6. 4, 5. Negative 3, 2. Gives us 4 times negative 3. Plus 5 times 2. So that's negative 12 plus 10, which gives us a total of negative 2. All right. All right. For the following, write in linear combination. I'm going to start with number 8 first. Here's the reason why. Linear combination is this. All right. You have vector, we'll call this vector U. All right, vector U. So you end up with U1I plus U2J. All right. So this is already in component form. All right, it's already in component form. All I gotta do is apply the first term. All right, 10. So it's gonna be 10I plus 21J. All right, U1I plus U2J. There it is. All right. Now notice this is already in component form. Number 7 is not in component form. Number 7 is polar points. All right, and these are the same points, if I'm not mistaken. No, they're different points. So I won't use them. All right, here we go. So we're gonna use these points right here. First, we have to put it in a component form. So if you remember, look at number 1. How do we put this in polar form? We did x2 minus x1 and y2 minus y1. And we got negative 5, negative 1. So now this is component. This is a component. There we go, component form. So now I can put in a linear combination. I have negative 5I minus, and the reason I did minus is because that's negative 1. Minus 1, minus 1J. Or you can say negative 5I minus J. Either one works. For this one, all right, this is exactly like, I believe it was number 3. Yeah, like number 3. So we have 36 magnitude times the cosine of 127. And 36 sine of 127. So I'm going to punch that in my calculator. 36 cosine of 127 gives me negative 21.7. And 36 sine of 127 will give me 28.8. So now I put that in linear combination, which is negative 21.7I plus 28.8J. All right, that concludes the front. Let's see what the back is holding for us. All right, for the back here, it says find the magnitude and directed angle. Notice these are already written in linear combination. All right, so we're first going to write this back as a component, which is -2, 7. All right. Now, remember the magnitude. All right, the magnitude of vector v equation is going to be the square root of x squared. All right, plus y squared. And to find the directed angle, we do tangent inverse of y over x. Now, the rule here is make sure you are in the correct quadrants. You know what? Here, give me a second. All right, there we go. Type it. It's better. I write real sloppy, so there we go. Now, after that, we need to make sure we're in the correct quadrant. How do we do that? Well, first of all, let's find the magnitude. All right, so the magnitude we're going to do, there's a component form. So the magnitude of this vector right here, we'll call it vector u. All right, is going to be the square root of -2 squared plus 7 squared. All right, so that magnitude gives us 4 plus 49, which equals the square root of 53. All right, now if my memory serves me correct, all right, 53 is not divisible by, 53 is prime. All right, 53 is prime. So with that being, all right, so now let's see here. That's the magnitude. That's prime again, so that doesn't break apart. So the magnitude is square root of 53. All right, now if you can reduce, reduce, but in this case we can't. Excuse me. All right, so we got our magnitude. Now, let's find the directed angle. So if we do the tangent inverse, all right, like that. All right, so tangent inverse of 7 divided by -2 gives us a -74. All right, 0.1. I'll say -74.1 degrees. Well, if you look at your unit circle, remember this right here is 0. If I go clockwise, this is -90, which means this angle right here that we're referring to, -74.1, is somewhere in this quadrant. All right, down here. But if you look at your actual component form, it is over here, -2, 7, right? Because I want left 2 and up 7, which means it's in quadrant 2. Well, how do I go from quadrant 4 to quadrant 2? All right, that's a straight line. So if we add 180 to this, that will give me my correct angle measure of 105.9 degrees. So here's the directed angle, here's the magnitude, and those are our two answers. Let's try this one. 12 and 9. All right. So, first of all, magnitude. Magnitude, again, I'll call this one V this time. All right. So we have the square root of 12 squared plus 9 squared. All right. So that's going to be 144 plus 81. All right, which gives us the square root of 225, and the square root of 225 is 15. So the magnitude right here of vector V is 15. All right. Now, we need to find the directed angle. So we do the tangent inverse of 9 over 12, right? and that gives us 38.9 degrees. So now, let's look at this. Yeah, that's positive and that's positive. That means it's in the first quadrant, right? Positive, positive. All right, therefore, this is positive as well. It's in the right quadrant. There's our directed angle. All right, there's our magnitude. There's our angle. And right here we have 5, negative 12. So, magnitude again. All right, we'll call this vector W. All right, so we have the magnitude of 5 squared and negative 12 squared gives us 25 plus 144. All right, which is going to be the square root of 169. Which is 13. All right. So there's our, oh, I put 30. I'm tripping. 13. There's our magnitude. Now, find our directed angle. First of all, what quadrant is that? 5 and negative 12. So positive 5 down 12. It's in this quadrant right here. So, let's see here. Tangent inverse of negative 12 over 5 gives us negative 67.4. Now, this is, guys, just like the first one, that's that negative angle right there, 0 and negative 90, is in the fourth quadrant. But, guys, I need to make it positive. I need a positive angle. All right, no negatives. So I need to go around one full rotation or 360 degrees. All right, and if I add that to 360, that gives me a grand total of 292.6 degrees. So there is our directed angle. There's our magnitude for number 12. All right. Right here, find a unit vector. So if you remember, the rule for unit vector is the unit vector is going to be u1 over the magnitude of u and u2 over the magnitude of u. So the first thing we need to do with these points right here is find the magnitude. All right, which we already did, right? We said that was square root of 53. All right, this is the same problem. So square root of 53, we know the magnitude already. So the magnitude of u in this case is square root of 53. We found it. If you don't know how we found it, look up here how I did that problem. All right. So now I just need to write my values over the magnitude. All right. Now, I know you already thought about it. You can't have a radical in the denominator. Yeah, absolutely. So we're going to rationalize this. All right. And so if you remember how to do it, you move the radical, the square root of 53, to the top. And then you keep the number from the radical at the bottom. All right. You keep the number from the radical at the bottom. And there you go. That's our unit vector for 13. I took up way too much space. For number 14, we already did it. What was the magnitude right here? It was 15. So I go, hold up, that's terrible. 12 over 15, 9 over 15. And now I know you already thought about it. I got to reduce. Okay, so 12 over 15, they both divide by 3. So that's 4 over 5. And they both divide by 3, so that's 3 over 5. There's our component, our unit vector right there. And we already found this unit vector. It turned out it was 13. So we have 5 over 13. The magnitude is 13, sorry. And negative 12 over 13. And those don't reduce, so those are our unit vectors right there. Okay, word problem time. Your favorite part. June, hold on, let me read this real quick. Alright. June went for her flying lesson. The plane was traveling 350 miles per hour, bearing 22 north of east. North of east, that's important. Alright, and it says here, the wind was blowing 45 miles per hour due west. I think that's important. What is the resultant speed and direction of the plane? All right, cool. So we can make 2 components right here. All right, and how we start that is, let me make this back bigger. The first vector given to us is the simplest one, 45 miles due west. So if you think about a compass real quick, I did not mean to do that either. If you think about a compass, right, you have north, east, south, west. So west, if it's blowing this way, that's a negative. All right, so negative 45, 0. It's going to be our first vector right here. So I'm going to call this one V1. Or V, vector V. We need to find our second vector, all right, based off the one I highlighted in the yellow, which was, they gave us a direction. They gave us a speed, and they gave us a direction or degree, directed angle. All right, so that vector is going to be 350 cosine of 22 and 350 sine of 22. All right. Now, how I explain this to my class, if you're watching this from another class, is this. I simply go, hey, where's your first pair? That's a pair. All right, 350 miles per hour bearing at a bearing of 22 north of east. That sentences together, that's one pair, okay? So now I just apply that, all right? And what we need to do first is simplify U, all right? We need to find the actual component form. So let's punch that in our calculator. So we have 350 cosine of 22 degrees is going to be 324. All right, and then 22.5. All right, and then right here we have 350 sine of 22, which is going to be 131.1. Now, we have our 2 component forms. For our resultant, what we got to do, and I call this vector R now, is we have to do V1, vector 1, or V plus U, or V plus U. I don't know why I still have 1 right here. Let's just call it V and U. All right. So vector V plus U. All right, so now this is U, guys. All right, that's U, that's V. So what I end up with is negative 45, 0. Plus 324.5, 131.1. All right, and I'm going to add those together. So in doing so, 324.5 plus negative 45 gives us 297.5, and right here, 0 plus 131.1 is 131.1. So this is vector R right here. So now we got to find our speed. Well, if you remember, speed is our magnitude of R. Vector R. So I'm going to do the square root of 297.5 squared plus 131.1 squared. And I'm going to do it all in one, 297.5. Here, actually, let me pull up the calculator on my computer. Hold on 1 second. All right, I don't know why I always say hold on 1 second, like you guys are sitting right here. Second square root of, I believe I said 279.5 squared plus 131.1 squared, and that's going to give us 308.7. 308.7. So 308.7 miles per hour. Is our speed. And now we got to find our angle. So to find our angle, because we need direction, all right, direction equals tan inverse of y over x. All right, so if I do that, let's go back to our vector r, 131.1 divided by 297.5. That's going to give us let's go to the calculator. 131.1 divided by 297.5. And we get 23.9. 23.8. So 23.8. 23.8 is going to be our angle. So the resultant speed and direction of the plane, guys, is 308.7 miles per hour at a degree of 23.8. Okay? So that is our wonderful solution right here. All right, if you got to question it, please review how I did this problem, because chances are doing the next one is the exact same way. All right. Now, let's look at this next problem right here. It says Orlando is tossing a football at practice, running forward at a speed of 3 meters per second. All right, so that seems important. 3 meters per second. He throws a football at a velocity of 35 miles per hour at an angle of 15 degrees. So, guys, that's one pair right there. That's the pair we're looking for. 35 miles per hour at an angle of 15 degrees. What is the resultant velocity? So, again, we got our two vectors. All right, let's make our two vectors. All right, so we have running for 3 meters per second. So we have 3, 0. All right. This is V. And then for U, so I gotta make this bigger, because if not, I'm gonna run out of space. See how big that looks right there? Gotta zoom in. So really you're writing smaller, you're just zoomed in. So here we go. V equals 3, 0. And U equals 35 cosine of 15. Hold up, let me make sure. Is that 15? Yeah. And 35 sine of 15. Okay. So I'm going to simplify U real quick. So 35 cosine of 15 is going to be 33.8. And 35 sine of 15 is going to be 9.1. And all I'm doing is round to the nearest 10th, by the way, guys. So anyway, R, vector R equals the sum of vector U plus vector V. All right, and that gives us vector R is 36.8 and vector V is 9.1. I'm sorry, 36.8, 9.1. All right, that is R, vector R. All right, now remember to find the speed equals the magnitude of R, vector R. So we have the square root of 36.8 squared plus 9.1 squared. So let me punch that in. .8 square root 36.8 squared plus 9.1 squared. There we go. And that gives us 37.9. All right, and while we're at it, let's just go ahead and find the tangent inverse. Tangent inverse, since I'm on the screen, tangent inverse of y, which is 9.1, divided by 36.8. And the reason I'm doing that is just so I don't have to redo it. 13.9. All right, so let's go back to our screen. We got our magnitude right there, and we got our directed angle. So, right here, the magnitude we said equals 37.9 miles per hour, or meters per second, excuse me. Meters per second, so 37.9 meters per second. And for our directed angle, remember you do tangent inverse of y over, man, I'm telling y'all, man, I'm rushing, trying to finish this before daggone I did the same thing. Over 36.8. All right, and that gave us 13.9 degrees. So, conclusion, our resultant velocity, 37.9 meters per second at an angle of 13.9. Gosh, sorry about that. I'm fumbling my words, please. Excuse me. All right. This next part right here is a complete review and going to be a part of your test, and it's never going anywhere, and it's going to be your all semester. Solving the equation using the inverse and trig function. So right here, a couple things. You need your unit circle right here. I don't have a unit circle present. You will need to pull out yours to understand what I'm talking about. Right here, you got to find arc sine of -1/2. All right, so actually, let me pull up a unit circle. All right, so real quick, back at the problem. We had to find arc sine or sine inverse. All right, hopefully you remember that. Sine inverse of -1/2. So remember, that's your y value. So if I look for sine inverse, also remember sine inverse is on this right half of the paper, on this half over here. All right, so where's the y value -1/2? Right here. All right, right there. Right there. Now, remember you have to use negative angles down here. Like this is -pi/6, right? All right, -pi/4, -pi/3, -90, or -pi/2. So -pi/6, okay? So I go back over here to the problem. This is -pi/6 right here. Right? Now, sine inverse of -1/2 is -pi/6. So now, so now we got to find the cosine of -pi/6. All right? So if I look back at this equation, the unit circle, you'll see that this is -pi/6. All right. So what is the cosine of that? It is radical 3 over 2, the x value. That x value right there, negative 3 over 2. And again, I'm sorry, man. Negative square root 3 over 2. I'm not spending a lot of time on these with much detail because this is something I feel you guys should know already. If not, I have other videos going over this stuff, so go look at it. For this one right here, this one is not on the unit circle. So I want to sketch this one out so you can see. This is cosine is, this is positive 8, positive 17. So we see that cosine is 8. If that's theta adjacent over hypotenuse. So if we use Pythagorean theorem, that's a squared plus b squared equals 17 squared. All right, we end up with 64 plus b squared equals 289. All right, and if we subtract 64, it gives us 225. So b squared equals 225, and then square root both sides, b equals 15. So this is 15 right here. So I use this to make this triangle right here. But anyway, we know what arc cosine is, 8 over 17. Well, what's tangent? If you remember, give me a triangle, so Couture, tangent equals adjacent. All right, tangent equals, opposite over adjacent. Or in this case, opposite over adjacent. All right, so this equals 15 over 8. And right here, same thing. All right, tangent inverse is over here in this quadrant. All right, the right half. So we have 24 over 7, or remember with a triangle, opposite, tangent, opposite over adjacent. So opposite over adjacent. Pythagorean theorem again, 24 squared plus 7 squared equals c squared. All right, so 24 squared is 576. All right, 7 squared is 49. All right, and that's going to give us 625. C squared. And then if you take the square root of that right there, you're going to get a strong 25. All right, so C is 25. So hypotenuse is 25. Now find sine. Well, remember sine is opposite over hypotenuse, or 24 over 25. Again, I have videos. Go back and look for them. They're on YouTube. They're there. All right. Graphing these real quick. This video is long. I'll tell you what. I'm going to stop right here, and I'm going to do these exclusively on their own little video. So I'll do the graphs on their own video, okay? I want you to be able to use those. I'll make that short and sweet to the point. I'll be specific with details into that video. So, man, yo, I hope this helps you in whoever class you got, man, especially my students. And I will catch you later. Peace.